Hello, everyone. Good morning. My name is Maiwa. I'll be taking you a topic called systems of equations. Systems of equations, or otherwise known as simultaneous equation. That's another way of saying it. So, for those people that are not cognizant with systems of equation, so another way of saying it is simultaneous equation. So I'm going to start from this perspective. So this is lecture 1. So we are moving straight to lecture 2 immediately we finish this lecture. So under system of equation, what is system of equation? Let me just start with this. For the first one, we are going to be looking at the definition of system of equation. I beg your pardon. Sorry. So systems of linear equation, a system of linear equation consists of two or more linear equations. I've already narrated the scenario for you that if you have a condition where as you have, if you remember vividly, what you have been doing over time is x plus 2x is equal to 0. This equation contains only one unknown, and also only one linear equation. Do you understand? Now, what if we have an equation whereby we have x plus 2y equal to 0, and we have x plus 3y equal to 2. Let me just stop right to here. So in this particular situation, you notice that we are having how many unknowns there? 2 unknowns and 2 linear equations. So the first one is x plus 2y is equal to 0, and the second one is x plus 3y is equal to 2. So that's why we said in this kind of scenario, we can say we have simultaneous equation. It can be more than 2. We can have 3 ways of writing this: 3x plus 2y equal to 4. This is another form of writing what? 3 linear equations. So now, what does this thing imply? So we move to the main work. Let me clear the screen so that we can continue. The solution of a system of linear equation in 2 variables and other pair that solve both of the linear equations. It follows a specific order. That's what I've shown to you in the previous explanation, that we have 2 unknowns. We might have 2 unknowns, and as well we have 3 set of layout, like x plus y is equal to 2, x plus 2y is equal to 4, and x plus 3y is equal to 6. That's an example of 2 or more linear equation. That's example of 3 linear equations. So we move on. So the next thing we are going to be looking at is the real life scenario of my explanation. So what is the application? How can we apply this? Let us quickly look at the second. Oh, apology. So the next one, how can we apply this? This is a real life scenario of my explanation. Let's say actually planning to store bananas and what? Onions inside 2 layout cabinets. And for each cabinet, there's a tendency, I have only opportunity to store banana in a separate compartment for the first layout of the cabinet, and there's another compartment for onions. Now, you know that if you have crate of egg, on a crate of egg, you can only place the egg or insert the egg inside that crate of egg. I think, to my own understanding, there are some that is 4, there are some that is 5. So you can only place it into that particular space, 5 in each row. Do you get it now? Let's say in this compartment, we can place bananas 2 in each row, 2 in the first compartment. So I can say for the banana, let banana be X and let our onion be Y. So for this first layer that you are looking at it here, because we might not be able to know the total number of bananas that are here, so we can say that we have 2x because we are inserting 2 bananas at a go plus 3 onions. Let me say 3y. But fortunately for us, the person that stored the bananas and onions in the first cabinet, he was able to state, or he gave us accurate information about the total number of bananas and plantains that he stored. So everything is 10, or let me say 10 or 15. Let me use 15. So the total number of all the bananas and plantains, add them together, everything is 15. That means 2x plus 3y is equal to 15. That's our equation 1. So the second cabinet, which is below the first one, we have 3x, 3 plantain, and 1 onions. So at the end of the day, you have the total number of both bananas and plantains stored in this second cabinet is 10. So the question now is, what is the total number of bananas stored in the first cabinet? And what is the total number of onions stored in the first layout in the first cabinet? So you can quickly depict that, you can get that using simultaneous equation. That actually leads us to this problem. And we normally use it to get what? Unknowns. If you know how we arrange things, and we'll be able to find out the way we can quickly picture out or quickly deduct the number of items that we have in each particular storage that we are storing our goods in. So if you can get the accuracy in lines of what you arrange, you can quickly get what you have stored. Do you understand? So that's a real life scenario of this. So let us go to the work itself. So I need to clear the screen. So this, picking my mouse. So picking my mouse, I'm moving to the next one. So I move. Now the next one is, how are we going to get 2x plus 3y is equal to 15 and 3x plus y is equal to 10? How are we going to find the unknown, the 2 unknowns that we have? So we have several methods that we can use to solve this problem. The first method we are having is elimination methods. So I'll quickly give us the true meaning of this elimination method. It's just like, from the word elimination, is we want to cut one of the unknown off for us to be able to get the other one. That's the basic explanation when you are trying to use elimination method to solve 2 linear equations. The second method is substitution methods. For the substitution method, you are making one the subject of the formula. From one of the 2 of your linear equations, you make one unknown the subject of the formula, then you insert it back into the second equation in order for you to balance off. So that's how to solve problem related to substitution methods. For the graphical method, under graphical method, this can only be we can only be able to use this method to solve two linear equations if we have our graphical book, our graph book, which is very essential for us when we are trying to plot the coordinates of the first linear equation and the second linear equation. So where both line meets is where our true solution lies. So I move to the next one. So let us start looking at what I've already mentioned here. Now, the first thing that we'll be looking at is substitution method. The substitution method. So what's the function of this substitution method? So we have basic steps that you have to follow when you're as well trying to solve a problem that is related to substitution methods. The first thing you have to do is you have to make sure that you make one of the variables, unknown variables or unknown value that we are looking for, you make that particular unknown the subject of the formula. After making it the subject of the formula, then you plug it back into the second equation. After that, you can now solve and get the unknown one for us to the second unknown. After getting the second unknown, then you now return that second unknown back to the previous equation that you were able to make the first unknown the subject of the formula for you to be able to know the first unknown, and you'll be able to get a value for that. So that's the basic explanation of what you are seeing on the screen. So I move to the next one. So let us solve. Now for the substitution method, we are looking at this problem. We have a problem on the screen. We are given this particular question, 2x minus 5. Oh, let me put equal to minus y. Apology for that. Let me just clear it so that I can write very well. Let's call this equation 1. This is our first linear equation. Our second linear equation states that x minus 6y is equal to 20. So absolutely, you could see that the first and the second one is like the previous explanation under the scenario, real life scenario explanation I gave the other time. So y minus 2x is equal to 5x, 8x minus 6y is equal to 20. That's the equation 2. So we have tray 1 and the second tray. So we have two unknowns on each particular cabinet, our cabinet. So we want to solve the problem. So how are we going to solve this problem? It's straightforward as well. So in order to solve this problem, the first thing we have to do is to make this the subject of the formula. So we are making y the subject of the formula, or y is equal to what? 5 plus 2x. Are you getting it? I think it's clear now. Y is equal to 5 plus 2x. So after doing that, we have to now insert this. Our y is 5 plus 2x. We insert it back into this equation here. So it's going to give us 8x minus 6, 5 plus 2x. I hope you guys are getting what I'm doing. I ought to have used the whiteboard, but I just want to quickly use this as an explanation. Then I'll make use of the whiteboard. So in the second, if there's any example, or when after I give I've given you, or after I give you assignment, after doing the assignment, we can use that one, the whiteboard, to do the basic correction. So it takes 6 times 5. 6 times 5. You could see that 6 times 5 is what? This 30, and this 6x is equal to 20. So that's why we have this here. So we move on. So we have 8x minus 12x. So we are going to have minus 4x. We are collecting like terms. So we take this 30 to the other side here. We are going to have 20 minus 30. Let us move to the next one. Let us see what you are having. Then, hope it is clear. Okay. So we'll move to the next one. I've cleared this now. I'm moving to the next one. Let us see what we have in the next page. Next page. Apology, please. Apologies. Apologies. Trying to get this done. Okay. For the next page, we have minus 4x is equal to minus 10. So we have to divide both sides by minus 4. After dividing both sides by minus 4, you see that this minus, the negative sign, we take off the negative sign. We can divide through by negative. So the negative sign, we take off the negative side. We are going to have 2.5 as our x. And you remember the equation, the previous equation, last one, when we tried to make the y the subject of the formula. This was our equation. So you plug in the y back into this equation. You are going to have 2 times 2, which is 2 multiplied by 2.5. It's like 2 plus 2.5 plus 2.5, which is 5. So 5 minus 5 is equal to 0. So our computation produced, please ignore this. Our computation produced 2.5. I'm sorry for putting that there. Just typographical error, and 0. So 2.5 and 0, that's the solution to this problem. So you can also check, let us check whether we are correct with what we have here. I want to check now. So if you have y minus 2x equal to 5 minus 5, let me just plug it, minus 5. So your x is 2.5, while your y, just note that your x is the first person that appear first, followed by y, according to our coordinates point. So we have 2.5, our y is 0, minus 2 times 2.5. 2 times 2.5 is 5 minus 5. So you could see that we're able to arrive at this point. So that's a perfect example, and we've gotten our answer right. We can move on. So let us look at the second method, which is elimination method. I think that elimination method to me is wow. But you can pick any method of your choice and make this a decision on that. I think depending on you, you can decide to use elimination method, or you can decide to use substitution method, irrespective of how you can quickly navigate through the principles and also the guideline in order for you to be able to arrive at your results. So we move on to the next one. Okay, the next one, apologies, please. I need to move to the next one. I need to clear my screen first. So solving system of linear equation by elimination method. So for the elimination method side, I told you this one of the superb method to me is straightforward. The only thing you have to be thinking of is you have to look for the first phase, the first tray at the upper side, and you look at below this tray. How are you going to quickly manipulate that? We actually depict how you can arrive at your solution at high speed. So if you fail to think deeply on what numbers you can quickly use to arrive at truncating the first unknown and the first similar unknown, then it will become a problem to you. So why solving um the equations? So let us move to the next one. So elimination method, I moved. So for the elimination, oh sorry, please apologies. Sorry. Now example one on the elimination method. So we have this kind of question. I think I'm tempted to use this whiteboard. Let me click the whiteboard. I'm going to use the whiteboard because I think we need the whiteboard here on the elimination method. Sorry. Sorry. Okay, we have 6y, 6x minus 3y equal to minus 3. 4x plus 5y equal to minus 9. So with this condition, the way I always ask myself first is between x and y, which one do I want to eliminate? So to me, we like to eliminate y first. I would like to remove this y first. So notice that we're having 3 here and we're having 5 here. These numbers, the first number here and the second number here, they are not the same. That is to say, minus 3y plus 5y will still give us 2y. There's still going to be 2y. So we have to look for a number at the upper side and a number below this side. I can multiply the two, which can make them to be having the same value, and for us to be able to eliminate both y at the upper side and the bottom line, the second tray. So to me, because if you look at this 3, I'll multiply 3 by 5, just exchange the number, and you come below this. I've used 5 here to multiply this first equation. So I'm using this, let me take this symbol. I'm using this this one that you're looking at here, 3 to multiply the bottom equation. So I think I'm good. So 5 times 6, that's 30. X minus 5 times 3, that's 5 times 3 is 15. You see, I'm doing it gradually. 5 times 3 again is minus 15. 5 times minus 3 is minus 15. You see that you're having minus 15. So we just retain your value. We move to the second tray. 3 times 4, that's 12. So we have 12x. 3 times 5y, because this place is positive, so you are going to have 15y. And also 3 times minus 9. 3 times 9 is 18. That's minus 18. Oh, sorry, 3 times 9 is 27. Apologies, please. Sincerely sorry for that, 27. Okay. So we cannot put addition sign because if you use subtraction, my plus we multiply minus, this will definitely give us what? This will give us minus 30. So it's better to use subtraction. It's just for us to add. So I can put my line here, 30x plus 12x, we have 42. Okay. And 52x, please. Minus 15 plus 15, we have plus 0 is equal to minus 15 minus 27. That's 5 plus 7, that's 12. I mean that 1. 2 plus 1, that's 3 plus 1 minus 42. So along the line, we have 4x, 42x is equal to what? 42. So the next thing we can now do is divide both sides by 42. We divide both sides by 42. So let me pick my writing material again. Writing 2. So my writing to this place will be 42x is equal to 42. So you divide this, 42 divided by 42. I think we are on the same page on this. Okay, 42 divided by 42. You remember this is minus. This is minus because we are bringing minus from there. So 42 then divided by 42. Our x will be minus 1. So the next thing is we now return, we can say, so we'll put x is equal to 1 minus 1. Let me just, sorry for that. In equation any of the equations, sure. So let me go to the previous equation 1. Equation 1. So if I'm doing this now, equation 1 says you might use the previous one that we probably start multiplying by factor of y. So minus 3. So our x is minus 1. So x into brackets minus 1 minus 3y is equal to minus 3. 6 times minus this minus 6 minus 3y will equal to minus 3. So let me collect the light terms. This one will go to this place. No, this is carrying minus. So we have minus 3y equal to minus 3 plus 6. Minus 3 plus 6 is 3. Minus 3y divided by 3 divided by 3. Just divide both sides by minus 3 so that our y can. So y is equal to 3. Y is equal to 1. Y is equal to minus 1. So our solution is minus 1 minus 1. So hope this is clear. So at this point, I'm going to stop. I'm going to, let me quickly go back. Let me stop sharing my screen. I'm going back to the previous one. Coming. I'm going back to the main screen now, main slide. So at this point, this is what we are having. Come on. So we have the continuation and we have this. So the elimination method, solving a system of linear equation by addition or elimination method. Write the equation in standard form, eliminate the fraction coefficient. So when you have a fraction, the explanation is just for you to understand how to solve a problem that is related to this. So this will be your assignment for today. I want you to do this and just attempt it. If you cannot, if you're having issue or challenges in solving this kind of question, you can reach out to me via my mail that is written here, mail@yahoo.com, or you call me, or you can chat me up on WhatsApp as well. That's my WhatsApp number you are seeing. So you can chat me up on WhatsApp, then we'll be able to look into it together. Then I'll provide necessary solution. Be expecting lecture 2 on graphical method, which I'm going to be doing tomorrow. I say Happy New Year. Have a wonderful weekend. Bye-bye.